This is the winter offering of Economic Foundations 2025. So number one, people got number one for the most part. A little bit of fuzziness on the definition of a budget constraint. What's important for explaining a budget constraint is that it's all about quantities of two things, right? It's the combination of, in this case, bread versus a composite good that you can buy given your income and prices, right? So it's points on the line, but every point is some combination of the composite good, and in this case, bread. So it's combinations of the composite good and bread that you can buy. Just as a difference curve, we erase this and then put an indifference curve through these points. Right, the indifference curve shows combinations of two goods to which a given individual is indifferent, economically indifferent, providing same levels of utility. So both of these are about combinations of these goods. Okay, question number two. This is the worker in the grocery store problem. The employer can give the person a price subsidy or they can give a cash grant of equal cost to the employer. It's the same thing. You have the government doing the subsidy, you can do private employer doing the subsidy. And the situation is starting out in equilibrium, point A, original budget constraint, indifference curve tangent at point A. Price subsidy swings the budget constraint out. Lower it for reflecting a lower price for food. There's going to be some new indifference curve, higher indifference curve representing more utility. In this case, getting the worker to point B. So in this case, there's quite an increase in the amount of food because the price has dropped and the worker goes for that. So that's just a simple kind of price drop. What happens to equilibrium. The key here, this is the Fabio solution. You can read that in the back of the book. You want to give a cash grant of equal cost, right? And equal cost is going to be the vertical distance. The cost is going to be the vertical distance between point B and where the original budget line is. You're drawing a parallel line to the original budget constraint, reflecting the fact that you've taken away the subsidy. Now you're just giving a cash grant. So another way of thinking about the cost is how much of a composite good can the person get? That's same distance, it's this distance. So the question is whether you'll get to a higher indifference curve if you're facing this dashed green line. I don't know if you can see the dashed green line. It's parallel to the original going through B. And if you look at the Fabio graph, it's very clear that, but not if you look at my graph, that this budget constraint has this area above the second indifference curve. It's pretty small here. It's bigger in the Fabio example, where a worker is going to be able to be better off with the cash grant than with the price subsidy. And that's generally true because when you rotate through point B, you're going to be getting opportunities above your second indifference curve that are opening up because of the cash grant. And that means that the person can be better off. So it's always going to be true, given the curvature of the indifference curves. Part B, even though it's clear, if you just give people cash grant as opposed to price subsidies, you can make them better off. Part B is more of a political economy question. Why don't all of our social net, safety net programs involve unrestricted cash? And the answer is that public sentiment demands that people who receive aid exhibit positive behavior, buying food, paying rent, and things like that. So that's why we end up with these subsidies as opposed to the cash grants. All right. So some of you took this to be the food stamp problem in figure 3.16. So you can look at 3.16. I don't need to put this graph up. The graph is very clear. In this case, the question is whether a certain income increase that's tied to the consumption of food is going to be better off, or is it going to make someone worse off than a cash grant equivalent value that's not tied to food. And what the analysis shows is that for a lot of people, it doesn't make any difference. But there are consumption possibilities opened up with this dashed line at the top of the budget constraint that might be a place where a consumer with certain preferences would go. So that I gave partial credit for, but it's not really what the problem was asking for, which was a price subsidy through some kind of a program. Okay, number 3. This is a market for coffee beans. We're given the supply and demand curves. Supply 10 plus Q. It's pretty obvious that's going to intersect down here at 10, right? When Q is 0, price is 10, and it goes up unit for unit. Slope is 1. Demand curve, Q is 0, starts up at 100 and comes down to 50. If the world market isn't part of the story here, we just get the intersection of these two. You can do it graphically, you can do it algebraically. I hope the two are going to agree, and they should agree on a price of $40 and a quantity of $30. Many of you cranked that out and used it as the initial answer. How much will U.S. consumers pay for Joel coffee beans? How many pounds per year will they consume? If there were no world market, that would be correct. And I did give full credit for that. But there's a world market, and the world market has a price of $30 for an unlimited amount of coffee. By assumption, the US market is small relative to the world market. So you got to think what that is going to do to the demand curve and supply curve. It's not doing anything to the demand curve because nothing is changing preferences on the part of US consumers. But the supply curve is going to look as it originally was. If the price is below $30, you only get domestic supply. So you've got this portion of the supply curve. But then there's unlimited supply available at $30. Okay, so this portion of the supply curve really becomes irrelevant. What matters is this portion of the original supply curve and then this horizontal portion of the supply curve. What this intersection point is going to be is given by plugging 30 in for the price. You're going to have then 70 equals 2Q, or price equals 35, quantity equals 35. All right, so the equilibrium price is going to be $30. This is before tariffs. And the equilibrium quantity is going to be 35 million pounds per year. So that's pre-tariff. Now with the tariff, we're going to be increasing the world price by $20. So that is going to change the supply curve. Now we have the relevant domestic supply curve going all the way up to 50. And only at 50 do we go off with a new supply curve that reflects unlimited world supply, but at $50. So, you know, this is a little bit tricky, but not that tricky. Just look at your supply and demand curves. If the relevant supply curve is going to be domestic all the way up to 50, and you ask what the intersection of consumer demand is going to be with this new supply curve, it's going to be the intersection that you originally obtained, right? The world market is irrelevant. We've priced the world commodities out of the reach, given the domestic supply of American consumers. So we're going to have no international supply. We're going to have no tariff revenue because all the supply is met by domestic suppliers. And we're just going to end up with this original 30-40 combination. And the amount raised by the revenue by the tariff of revenue raised by the tariff is going to be zero. All right. So usually tariffs aren't so extreme that they totally price a good out of the market. They're going to increase the cost, reduce the amount of world market goods transacted in the US, raise some revenue for tariff, but in this particular example, there's nothing. There's no tariff revenue at all. We've always been drawing difference curves so that they are convex to the origin. Draw one that is concave to the origin and show that it doesn't exhibit a diminishing margin rate substitution. Let's start with the convex case. I've drawn it here. And if you have a convex curve, the slope is steeper up here, reflecting the fact that you're willing to give up a lot of the composite good to get a little bit more of whatever X is down here. On the other hand, once you're down with very few units of the composite good, they're precious to you, so you're only willing to give up a little bit to get that same addition to X. So that's the convex case, and that reflects diminishing margin of substitution because the slope up here is steeper than the slope down here. If something is concave to the origin, that would be in a difference curve like that. And now, the slope is flat up here and steep down here. So the more you have of the composite good, the less you're willing to give up to get X relative to a situation where you've got very little of the composite good. All right, so if you've got this continuously increasing slope, you don't have diminishing margin of substitution. You've got increasing margin of substitution. And it all comes from this concave indifference curve. So because the idea that there's a diminishing margin of substitution is so appealing, we draw our indifference curves so they're convex to the origin. Okay, last question, number 5. Suppose the government imposes a per unit tax of $10 on producers of good X. A per unit tax, $10. Are producers likely to bear a higher burden of the tax in the short run or the long run? And then illustrate your answer with graphs. So just start out with a typical demand curve that's not perfectly elastic or perfectly elastic. Supply curve, same thing. Before the tax is imposed, you're going to get an equilibrium where the original supply curve crosses the demand curve, and a price is going to be established, in this case, P1. A per unit tax is going to shift the supply curve up by the amount of the tax. And there's going to be some new equilibrium, P2, a new equilibrium price. And if we define the consumer burden as the price increase, P2 minus P1, expressed as a fraction of the tax is this vertical distance, which is P2 minus P3, you can see that maybe, 2/3 of the tax increase is passed on to consumers in the form of a higher price. All right, so the question asks, what's going to change if we have a long run supply curve instead of a short run supply curve, right? In the long run, suppliers can make any decision about production that they want. They're not constrained by the equipment that they have. They're not constrained by any of the other kind of investments that they've made in production. So they're free to choose the production technology that produces whatever this is at the lowest possible cost. So you're not going to get this increasing demand for higher prices as supply expands, because supply is going to expand indefinitely at the same cost. Costs aren't rising in the long run. So now we've got a situation where instead of a upward sloping short run supply curve, we've got a perfectly elastic supply curve. Supply curve, long run, pre-tax. All right, and let's have it still come over here to P1. Demand curve is probably going to become more elastic as well, because there's more of a chance to substitute. And that's going to change a little bit of the burden. Well, if supply is perfectly flat, it's not going to change the result at all. Let's do that first. Let's assume demand doesn't change. Demand short run equals demand long run. And now we've got a supply curve that's shifting up by the amount of the tax. It's going to shift up higher than P2, right? P2 was the old price increase when supply was not perfectly elastic. So we're going to get a new P2 that reflects that same $10 per unit tax. This is a supply long run post-tax. And you can see, as long as the supply curve is perfectly elastic, you're going to be shifting the full burden of the tax onto consumers. So the producers are going to have none of the tax burden if their supply is perfectly elastic. And you can see, you can flatten this demand curve out, but unless it becomes totally flat and the supply curve is perfectly flat, you're always gonna have this upward shift. That's a full amount of the tax, which is to say consumers are gonna pay the full burden of the tax, bear the full burden of the tax, if supply in a particular market is perfectly elastic. And then the second part was to illustrate with graphs.